Hi guys, welcome to our lesson on rescue awareness and operations. EMS personnel usually have no trouble reaching their patients, that is, unless they are pinned beneath a vehicle, trapped in a collapsed building, or injured climbing a rock face or crawling into a cave. When people get injured or stranded in such situations, often someone must first rescue the patient before emergency medical care can even begin. So what does rescue mean? According to the dictionary, it is the act of delivering from danger or imprisonment. In the case of EMS, rescue means extricating and/or disentangling the victim who will become your patient. Without rescue, there are no patients. We've got to kind of keep that in the back of our mind as we begin to progress forward through this lesson. Let's go ahead and get started. Our topics for today will include the role of the paramedic, protective equipment, proper safety procedures, and rescue operations. We'll talk about surface water rescues, some hazardous atmosphere rescues, along with highway and vehicle operation rescues, and then hazardous terrain as well. Again, we know that by definition, rescue is the act of delivering from danger or imprisonment, right? In EMS, rescue means to extricate and/or disentangle the victim who will then become your patient. We know that oftentimes the inability for us to gain access to our patient or to only have limited access really can prolong the care that's necessary to save a life. We'll dive into that a little bit further. We have to also discuss what the role of the paramedic is, because in rescue and operational components, the role of the paramedic is more patient care driven than it is rescue or recovery type aspects. The role of the paramedic is primarily awareness and training that imparts knowledge about rescue operations to the EMS personnel. So you have an idea of what type of rescuing occurs in the pre-hospital setting with the use of fire and other public safety services. In any rescue situation, treatment begins at the site of the incident, where the patient is. Paramedics should always have the proper training and have the proper personal protective equipment to care for that patient. If we don't have the right tool, then we shouldn't be performing that task. The other thing that goes along with that is we have to have proper training. You also have to recognize, what hat are you wearing at the time? Are you a paramedic on the ambulance? Are you a paramedic with a rescue fire squad? Or are you a rescue personnel not providing medical care? Where do you fall in the continuum of rescuers and being a paramedic? Paramedics should understand the hazards associated with various environments. And we've discussed this throughout the program and throughout our simulations. It's important for us to be able to recognize when it is safe and when it is unsafe to access our patients. This goes back to situational awareness, making sure that your head is on a swivel and that we're constantly on the lookout for hazards or safety-related issues. Now, as we talk about safety, protective equipment is at the forefront of everything that we do. We know that for rescue or protection, we need to have visible clothing, something that's going to allow for us to be seen at night or with reflective materials. We also have to be able to adapt our PPE based on the circumstances that we're up against. Maybe in the case of COVID, we were dealing with the PPE shortage. Maybe for a rescue issue on the side of a scene in extreme temperatures, we may have to be creative in how we provide protective equipment to the rescuers to prevent heat exhaustion. And remember that PPE may not completely prevent exposures to infectious disease. It's really more along the lines of helping to limit the exposure that we have while keeping the rescuer safe. We know that protective equipment in this case includes things like helmets, which are governed by the NFPA laws, eye protection, those could be goggles, safety glasses, or face shields, hearing protection, respiratory protection, which could include everything from a dust mask, surgical mask, to an N95 mask as well, or even some type of PAPR-related system. Gloves, which could be gloves from rubber gloves to construction gloves to auto extrication rescue gloves. We know we need to protective equipment, especially if we're going to be around the potential for any explosive material or for a fire to be produced, and that is some type of flame protection and coats or turnout gear type components you would see normally worn by firefighters for structure firefighting gear. We also know that we need PFDs, or personal flotation devices, for any type of water rescue, proper lighting, hazmat suits if we're dealing with any type of hazardous material, and then wilderness protection depending on the circumstances and the environment that we're working in. Now, for patient protection, we also need some of those same types of PPE. However, in this case, we're now worried about protecting the patient from injury or exposure to their environment. These again include things like helmet, eye protection, hearing and respiratory protection, protective blankets, which is extremely important, and then protective shielding where it's feasible. Now, there are a number of safety procedures that we have to consider as we deal with rescue and operational situations. We know that we have to take steps to curb the heroics and maintaining the optimum safety. We know that when it comes to the heroics, oftentimes those that are referred to as heroes are those that are dead. We know that we're all here to make a difference in the impact of our community and to our patients, but we cannot take extreme risks when it's unnecessary. Our safety needs to come first in order for us to properly and safely take care of and protect our patients. For these types of components, we need to have certain operating procedures, including things like rescue, SOPs, specific crew assignments, and pre-planning to ensure that proper care and strategic interventions are utilized appropriately. When it comes to rescue operations, there's a number of roles in which the paramedic will play. Let's discuss those further. During a rescue operation, there's a total of 7 phases to the rescue. The first phase involves the arrival and setup for rescue. Phase 2 is identifying and controlling any hazards in the situation. Phase 3 is gaining access to our patient. Phase 4 is now providing medical treatment. This is where the paramedic will have a major role. Phase 5 may be disentanglement or the true rescue aspect. Phase 6 will include packaging the patient for export out of the environment. And then phase 7 will be the removal and or transport of the patient to an appropriate facility. Let's look at each one of those a little bit more. During the arrival and scene size-up phase, we need to do things such as establish medical command, conduct a rapid scene size-up, and be careful not to overestimate your capabilities to handle a rescue situation. One of the most important things that we can do to help our patients is know your limitations. Know where your training and expertise ends, and where the next level of provider or expert comes in. For phase 2 of hazmat control, on-scene hazards must be identified with speed and clarity. There is no room for error when it comes to life hazards. We know we want to control as many of the hazards as we can, but not always will it be possible for us to control all aspects of hazards. Again, that's part of the reason why we're having specialized personnel to help assist in the rescue. And then we need to continuously be on the lookout for new and other potential hazards that may arise or develop throughout the rescue. Phase 3 is the patient access phase. This is begun by formulating a plan on how we're actually going to be able to get to our patient. How can we gain access? The use of appropriate safety equipment and procedures must be employed in order to ensure that all providers and patients are properly cared for in a safe and effective manner. We know that prior to any gaining of access to our patient, that a formal briefing should be held for rescue personnel before any efforts begin. Again, communication is key to an effective rescue. Phase 4 is the medical treatment. There are 3 primary responsibilities that you as a paramedic will take on during the rescue. The first is the initiation of patient assessment and care as soon as you possibly can. Oftentimes that may be delayed based on issues gaining access or issues of even being able to properly assess all parts of your patient. For example, if a victim is entrapped inside of a vehicle and you're only able to gain access to one of the victim's arms, that may be the only portion where you can initiate your assessment based on things like pulse oximetry, pulse rate, cap refill, and that's it, based on the exposing limb that we see in that type of circumstance. The second responsibility that paramedics have is the maintenance of patient care procedures during disentanglement. Once we begin care, we're not going to abandon our patient. We must be there through the detanglement process. That means paying close attention, being an extra set of eyes and ears for safety, and being an advocate for your patient, recognizing that sometimes the most efficient way to do things is not always in the patient's best interest, and you may have to shine some light on that based on your medical expertise. The third responsibility that you have is the accompaniment of the patient during the removal and transport. Again, once we establish care, we need to maintain it, and that means throughout the disentanglement, throughout the removal, and throughout transport to a specialized facility of their need. Again, we want to identify and care for existing problems anticipate changing conditions, and determine in advance the assistance and equipment that's needed at the patient's side. We also want to continuously evaluate the risk for both the rescuer and the patient. Stage 5 is the disentanglement. Again, there's additional responsibilities here that we have to be aware of. These include personal and professional confidence in the technical expertise in the gear that's being utilized to rescue the patient. We have to trust and walk with faith when it comes to our rescue experts and our technical experts. They test their gear, they're the most comfortable and familiar with it, and we need to be able to have faith in their confidence and their expertise. We also know that we need to have a readiness to provide prolonged patient care. Not always is the disentanglement going to be something that happens within an hour, within 3 hours. It could be even longer before that patient is able to safely be removed from the environment and then prepared for transport. So be prepared to have that prolonged patient care. And you may have to think about long-term resources for that patient rather than the acute, short-term things we typically deal with in the pre-hospital setting. Lastly, we need the ability to call for and/or use specialized rescue resources. Again, that goes back to knowing your limitations and being able to ask for assistance when it's indicated. Phase 6 is the packaging of the patient. For this, we need to make sure that we have a safe process involved for all rescuers and the patient. That means before we consider moving the patient needs to be secured properly. We also need to have a means of egress in case something were to go awry, a way in which that we could have an exit point that would be best for both the patient and for us providers. Not always is the path of least resistance the best egress. Factors that for time based on the patient's medical condition we have to account for. Again, recognize that we may have to try to package a patient appropriately when they need to be having expedited transport, but we have to recognize packaging is very important for safely transporting. And then properly package the patient to prevent any additional injuries during their actual extraction. This could include the use of like a Stokes basket or a rescue basket. It could be utilizing ropes and pulleys. This could be a number of different things, including cribbing or boarding that helps stabilize structures. All of these things need to be considered and utilized properly before we begin transporting the patient. So remember, properly package the patient just to prevent additional injuries, and make sure you take that extra time and thought about your patient's safety. Our final phase is phase 7, which is the removal and transport phase. This requires a coordinated effort on all personnel's behalf. We have to make sure that everyone's on the same page and that we all work together for a common goal. We want to coordinate decisions regarding transport as early as we can to anticipate ongoing issues. And remember, from a patient care standpoint, we need to make sure that we continuously perform an ongoing assessment during the removal and/or transport of that patient. Now, if we switch gears a little bit, we can talk about surface water rescue. In Michigan, we're never more than a mile away from some type of surface water. Makes the potential for a water rescue or a surface water rescue relatively high. Let's dive into that a little bit further. We know that water rescues may involve any kind of body of water. These include things like rivers, pools, streams, canals, or lakes, flooded gravel pits, or even the ocean in some states, not Michigan necessarily, but the Great Lakes especially. We know that when paramedics are participating in water rescues, they need to be properly trained and equipped in order to do their job effectively. You as a standard paramedic may not have the required training or equipment to perform a safe water rescue. When surface water rescues need to be employed, we need to recognize there's some personal protective equipment that we need to utilize regardless of our involvement within the rescue. One includes the use of PFDs, or personal flotation device. Always wear a personal flotation device whenever you're around any type of body of water or ice for that matter. And then make sure that you become familiar with safe aquatic practices. Make sure that if you don't know how to swim, that you're not going near water, that you're using your proper flotation device, and again, you're only utilizing your skills and training based on what is safe and recommended. We also have to recognize that water temperature plays a major role in access to our patient. It also has a major issue of dealing with hypothermia. Even though we may be in the middle of summer with a 100-degree day, it's possible the Great Lakes may have a temperature in the 60s. And again, that can lead to issues with contributing to hypothermia. We know that factors when they contribute to hypothermia, we have incapacitation and the inability for the individual or the patient to self-rescue. We also know they have the inability to follow simple commands and directions. They have the inability to actually grasp a line or a floating device. Think of if you ever put your hands, normally in class we'll have you put your hands into a big bucket of ice water and put it there for 1 minute and then ask you to snap your fingers. It's almost impossible to do simple maneuvers because you'll lose the dexterity in your hands because of the hypothermia setting into the muscle. We also know it's possible if someone were to swallow water or get cold water splashed onto their larynx that we could develop a laryngospasm. When a laryngospasm happens, it's a reflex that prevents the lungs from filling with water. As that water touches the larynx, it slaps the larynx shut and prevents additional water from coming in. We used to refer to that as a dry drowning. What we do know is that laryngospasms can be good for the patient in the short term, but when it comes to managing their airway after a rescue, it can become a major concern. No airway, no patient. We may actually have to break that laryngospasm by applying the bag valve mask and slowly ventilating the patient in order to try to break open that laryngospasm. We also know that when people are in an emergency and need to try to preserve heat, that we can encourage them to do the HELP position, which is the heat escape lessening position. We'll talk more about that here in a second. Basic techniques for rescue, obviously PPE. For ice rescue, most likely you're going to see the use of a dry suit that's going to help protect the rescuer from any of the cold environment or the cold water exposure. Remember the reach, throw, row, go from basic EMT? That's the model we utilize for water rescue. First, we try to reach them. If we can reach them, we will grab them. If we can't, we're going to throw a buoy or some type of flotation device to them. If that doesn't work, we're going to try to row a boat or row some type of craft to get to them. And last but not least would be go, where we would actually go into the water to rescue that individual. It's very important that as a paramedic or as a rescue provider that you're proficient in throwing a water bag. When you throw a water bag, and you can see that's what the gentleman has here in the picture, you can actually throw that and you should throw it past your patient. It's better to throw things past the patient. One, we're less likely to hit them, right? Two, it's much easier for them to grab onto the line, and as we pull the bag or pull the rope, it's going to allow for that buoy or that rope bag to travel past them, giving them a better likelihood of grabbing onto it. But again, PPE and the proper reach, throw, row, go procedure and the proficiency with the water throw bag are common things that a paramedic may need to do, as you may be the first ones on scene. When it comes to moving water, we know the most dangerous water rescues involve water that is moving, water that has kinetic energy. We know that the hydraulics of moving water are going to have a lot of components, a lot of variable components in regards to how you will be able to safely rescue that individual. These include things like water depth, the speed or velocity of the water, are there any obstructions to the water flow, changing in tides, rip currents, and more. We know 4 swift water rescue scenarios can exist, and we'll take a look at some of those as we go through. One of the first one is a recirculating current. This is where we get the creation of what we would refer to as a drowning machine. In essence, this recirculating water will continuously suck the provider down or the patient down to the bottom. And even though the surface of the water may look very calm, very tame, once they're caught into this cycle, it's very difficult for them to be able to escape. Generally, in these circumstances, it's not going to look good for your patient, and the rescue may become a recovery over just a matter of hours. Strainers are another component we deal with. Strainers are just like you would think at home when you cook pasta and you dump it into a strainer and drain it out. Water is going to be able to flow through a strainer, but bodies and patients and equipment debris will become trapped in that obstruction. A prime example is a downed tree. Downed tree in a river doesn't look to be that big of a deal, but when the water is moving, as current is moving and against it, it's going to trap that patient up against a trainer, and the strainer, pardon me, and it becomes very difficult for them to be able to become disentangled. The goal, if we know that there's someone is in an area where there are strainers and they're coming up to it, we don't want them to grab onto it. We want them to try and swim over it if possible, as that's going to allow for them to continue to move with the current of water and refrain from getting trapped or entangled in that strainer. We also know that foot and extremity pins can happen as well too. Anytime that we're dealing with fast moving water over knee depth, we should not be walking across it. If it's above your knee, there is an extreme danger of either becoming entrapped or getting pushed over by the current because of the amount of kinetic energy that water has rushing forward. If we're dealing with someone who has their foot or extremity stuck, to remove it, it must be extracted in the same way that it went in. So if their leg went in a direction like this and they had to get pulled forward and the current is pulling them, the only way to get that out is to remove it in the exact same way in which it went in. We also have to talk about dams and hydroelectric intakes. There are a lot of these that happen, especially along rivers here in Michigan. The height of the dam is no real indication to the degree of hazard, as this, again, just like we had talked about with some of our other circulating components, create like a drowning machine. These intakes actually become just like a strainer and will suck the patient down in and keep them pinned underwater as the water moves past them through the dam. Again, oftentimes these rescues can only take place once the dam has been shut down, and we can then begin to have more of a recovery than a rescue. Again, we talked about some of these self-rescue techniques, including the use of personal flotation devices, the HELP technique when it comes to maintaining warmth in order to keep their body close to them, along with some other techniques. Now, flat water rescues are something else that we have to deal with. We know a large portion of drownings or near drowning incidents take place in flat or slow moving water. Generally speaking, alcohol or other illegal substances play a significant factor in the cause of these types of incidents. We know when we think about these survival factors for flat water or slow moving water rescue, it has a lot to do with their proper safety precautions. Do the people on the boat or craft have personal flotation devices? Is there some type of cold or protective response from the body that's been activated? In this case, it would be an example of the mammalian diving reflex. That's why we always say you're not dead until you're warm and dead. The cold actually will slow down your body, slow down your heart rate and metabolism. That's the mammalian diving reflex. If you were to take your face and put it into a bucket of cold water, you could actually watch your heart rate drastically slow down. We're also going to know that we're going to have a location of submerged victims and then recognize at some point the rescue procedure will move to a body recovery-like procedure after a period of time. Again, factors affecting survival. We know that oftentimes we need to employ proper in-water spinal immobilization techniques where appropriate. And then we know that these typically will occur in our first 3 phases of a rescue situation. Now, when we talk about hazardous atmosphere rescues, again, this is an area that we're going to assist more than we're going to provide rescue components. But we have to recognize that the paramedic plays a role in hazardous atmosphere rescues. One of the most serious threats of confined space rescue is an oxygen deficient environment. Things like a grain silo or a drainage ditch or a tunnel or cave, oftentimes because of the confined space, will have a limited amount of oxygen in that environment. 60% of all fatalities are people attempting to rescue a victim. We know that oftentimes the rescuers can become victims very easily if they're not concerned or not taking proper safety precautions. We also know that with confined space, if we were to define that, it would be any space with limited access or egress that is not designed for human occupancy or habitation. Manhole covers, drain ditches, grain silos, those are some of the more common ones that we typically see. We also know that with hazardous atmosphere rescues, entering a confined space, such as a silo, requires training equipment, and experience, much more than what the paramedic will be provided with as part of their exposure to hazardous rescue and operations. With confined space hazards, there's several things that we need to be aware of. First are those oxygen-deficient atmospheres. We also have to be aware for toxic or explosive chemicals, engulfment with flame, machinery entrapment, if there's any type of electrical components or electrical concern for electrocution, and then structural collapse concerns. Is it a safe environment for us to be able to get into? Or do we need to stabilize the environment before we can actually begin to go after our patient? And again, this is really done in conjunction with those that are properly trained with the proper equipment, the experts in confined space and the experts in hazardous material rescue. We know that for confined space protection in the workplace, employers must provide a training program for all employees who work in or around confined spaces. There's also a permit process that they have to go through to maintain their ability to work in those confined places. The types of emergencies that we would generally see in these include things like falls, medical emergencies, which are oftentimes are hazmat related. Again, the oxygen deficiency or asphyxia type emergencies, explosions, fire, or entrapments. With cave-ins and other structural collapses, we know that collapsed trenches or cave-ins can occur in almost any community. Most of these types of cave-ins will occur in trenches that are less than 12 feet deep and less than 6 feet wide. And in this case, the side dirt on that trench will become unstable and then fill the trench in, potentially trapping anyone who's in that trench at that time. Again, we talk about reasons for collapse. These include things like the contractor disregards safety regulations and puts themselves at a higher risk for a collapse. We also know that the lip of one or both sides of the trench can actually cave in, or the walls of the trench can actually shear away and fall in entirely. Oftentimes when they're digging a trench, all the dirt and material that they're bringing up, they refer to as their spoil pile. Well, if that spoil pile is too close to the edge of the trench, it can actually cause a shifting of that material and a cave-in as well. And then things like water seepage, ground vibrations, intersecting trenches, or other previously disturbed soil all puts a much greater risk for a collapse occurring in a trench. When we have a rescue from a trench, we know that even though that we're in there to rescue, a secondary collapse is likely. If one has happened, another one is likely. We know that we need to secure the scene, establish command, secure a perimeter, and immediately summon a team of specialized personnel for a trench rescue. Proper shoring must also be in place in order to maintain the environment safely as the rescue continues and ongoing interventions are performed. For highway operations and vehicle rescue, again, a number of components we'll talk about. Mostly when we're dealing with highway operations and vehicle rescue, traffic is one of the biggest hazards that we associate with. Traffic flow is the largest single hazard associated with EMS highway operations. And so when we're on the side of a road, on the side of a highway, we need to make sure that we're conscious of our surroundings. We want to do what we can to reduce traffic hazards where possible. These include things like staging your vehicles to protect the scene, positioning of apparatus to close down or to make physical barriers to your scene, minimizing emergency lighting as far as your vehicle lighting and increasing your scene lighting. Maybe we need to have the traffic redirected to a better location, and then maybe we're going to put up street signs or warning signs well in advance of the accident to ensure high visibility. Maybe also we're going to utilize our traffic safety vests in order to make sure that we as providers and rescuers are visible as well. Now, other non-traffic related hazards that you could see as a paramedic include fuel or fire related issues. Maybe it's an alternative fuel situation where you're dealing with a car that works on hydrogen, or maybe it's some type of electrical powered or hybrid car. They could be sharp edges or objects, energy absorbing bumpers where they compress in and have the potential to release massive energy if they were to be put under stress or excessive heat, airbags, hazardous cargoes, rolling of the vehicles themselves, or any type of vehicle or ground that may be unstable. We also have to recognize the anatomy of our vehicles as well, or auto anatomy. Motor vehicle collisions present EMS with the most common access and extrication problems that we can see. You must know some of the basic information about an automobile construction or anatomy to be able to effectively communicate and assist in the rescue. Some of these considerations include frame and body construction, recognizing the different types of pillars, knowing that your front windshield pillar from the side view of your car is referred to as the A post, B post, C post, and so on. A school bus may have all the way through Z posts, but that's how you would identify them, and then identify them based on driver's side or passenger side of that vehicle. We also know that firewall or engine compartments or components can be an issue when it comes to rescuing, the types of glass, safety glass versus a laminated glass, and then doors, if they're having special types of locks and components that we may need to remove or impede in some fashion in order to gain access to our patient. There are some strategies that, again, we can employ to help us improve our rescue. These, again, include things like performing a scene size-up initially, working to control and identify hazards, assess what the degree or level of entrapment is, make sure that we establish a circle of operations so we know who's in that group and who's working to help rescue that patient, and then making sure all hands are on deck for treatment, packaging, and removal of our patient from the vehicle. Now, a lot of these practice skills that you will see in rescue situations we use pretty commonly. We know that practice and or observing the various disentanglements or extraction skills that are commonly used is going to be a great tool for you. And you're going to gain a lot of experience throughout your clinicals, your internship, and then as a provider as well. Make sure that you become familiar with the use of the hydraulic rescue equipment, the jaws of life, or the spreaders or cutters or hydraulic ram tools, airbag equipment, cribbing, chucks, all those things that you need to be aware of as a provider, because that allows for you to be a second eyes and ears, not only for your patient's well-being and safety, but for all those the rescuers to make sure that they're safe during the rescue. Again, we talked about a lot of these different types of equipment throughout the program. Airbags are synthetic bags available in various shapes and sizes that, when inflated with air, have a very great lifting capability and for stabilization. A come-along is a ratchet-type device that utilizes to pull a load in a straight direction. Cribbing is an example of 4x4 or 2x4 block cut into about 18-inch long sections that allows for us to use them like Lincoln logs and kind of crib up a section to stabilize a vehicle or stabilize an object. We have hydraulic cutters, which is a hydraulic power tool that we use to be cut metal of a vehicle or other components. A hydraulic ram that pushes or pulls in a straight direction, and then a hydraulic spreader that can easily be used to force open, spread, or separate items such as a vehicle door. We also have things like jacks, which are common for lifting devices. We may have a number of jacks that we use. Step chocks, these are similar to what you would see with cribbing, but a step chock is where you're going to see steps typically made from wood or some other type of plastic or rubber that can be utilized to stabilize as well. A wedge, which is a 4x4 that basically is going to be cut on an angle to become to a point at one end where we can use that into fill in gaps and whack with a mallet in order to stabilize and create some tension in our cribbing and in our step chocks. And last but not least is a winch. This is typically a powered reel cable that's typically electric or hydraulically driven, normally mounted to a truck, or sometimes they're put onto a truck, or there's multiple different ways that a winch can work. But again, it's used primarily for pulling. We also have to recognize that not all vehicles are created equally anymore. Hydraulic vehicles or hybrid electric vehicles contain both electric motor and an internal combustion motor. And now with primarily just electric cars, we know these pose a huge risk as we're beginning to cut or extricate a patient from a vehicle, because cutting any of the type of these high voltage components make a huge risk not only for your patient but also for you and those around you as a rescuer. It's very important that you take control and turn off the vehicle and remove the key, and be aware of the specific requirements for electric and hybrid electric vehicles when you're dealing with an extrication. Again, use those that are experts to help you navigate this. There's also a number of apps that you can utilize that will let you know for extrication procedures where it is the safest way to disengage the battery or to disengage the power source for that vehicle. We also have hazardous terrain rescues that will happen from time to time. Activities such as mountain climbing, rock climbing, cross-country skiing, snowboarding, snowmobiling, hiking, camping, any of these things where we're dealing with rugged areas, we should know how to perform the care that's needed for that patient. We should know how to perform a litter evacuation. A litter evacuation is in essence the use of a Stokes basket or rescue basket to actually lift an individual without causing any other injuries to the patient or other rescuers. We know that if we're dealing with a steep slope or a low angle like terrain, that it can be accessed by walking or kind of scrambling back and forth as you go down that hill. For vertical or high angle terrain, usually it involves a cliff, a gorge, or a side of a building, or some type of terrain that's just so steep, that hands have to be utilized in order for you to go up or to go down it. That's the kind of an idea of when you think about a steep or low angle versus a high angle type rescue. Flattened terrain typically can pose a challenge if there's a number of obstructions, including things like trails or paths or creek beds, any type of obstruction that would prevent you from gaining access or removing access, moving your patient from the scene, I should say. With high angle rescues, they must have extensive initial and ongoing training in order for you to perform any type of ongoing high angle rescue. We have to be aware of some terminology, aid, anchor, belay, and rappel. These common terms are going to help you be able to communicate and are taught extensively in high angle rescue training. For low angle rescue, again, we're talking at a low angle rescue that's up to a 40-degree angle, but not above. Low angle rescues involve less technical skill than high angle rescue, but it may still involve some additional training, and ongoing training is going to be essential as a paramedic in maintaining your ability to facilitate the rescue and again provide that continuous patient care. When it comes to patient packaging, one of the biggest tools we'll utilize is the Stokes basket. It's the standard litter for rough terrain evacuation. We can immobilize our patient as needed, put them into the Stokes basket or into the litter, properly secure them, and then allow for them to be removed from that environment safely. Again, it provides a lot of additional strapping, all again to make sure the patient remains safe and protected as they go up. For example, on a cliff, you may have your patient backboarded, but if they were not placed into a Stokes basket or a litter, as that backboard is lifted up that cliff, they may actually hit the wall of the cliff and they're going to get additional injuries. That's not what we want to do. The Stokes basket allows for that basket to scrape up against the side of that cliff without actually causing any further damage or concern to our patient. When we utilize the Stokes, again, we want to apply the harness to the patient, make sure that we're going to utilize the leg stirrups, which allow for them to be able to be raised up if they need to. We're going to make sure the patient, again, is properly secured to the litter. We're going to tie the tail of one litter to the line on the patient's harness. In case something were to happen, there's a secondary catch. And then we know we need to make sure that that patient has a helmet on or some type of shield-like covering for the Stokes basket or the litter altogether. And again, we can still administer fluids to our patient as this is happening, but again, it's going to have to be pre-planned in order for that to be effective. We also want to allow for accessibility for taking blood pressures, performing airway management and suctioning, and then assessing distal perfusion, things like your wrists and your feet. We want to ensure that we've got plenty of padding to make the patient as comfortable as we can, and then consider if it's a cold or a hot environment, what can you do to help heat or cool the patient to maintain normal thermia. We also want to provide for an airway clearing system via gravity to the trip line. Right? So if we need to have some type of airway cleaning, that we can do that through a line we can pull to tip the patient on their side. Like, for example, if they were to vomit, it will give us the ability for them to maintain and clear their own airway. When we're dealing with the removal from the hazardous terrain, for flat, rough terrain, we need enough people to be able to carry the litter. That typically is 2 to 3 teams of 6 carriers. That's a lot of people. These devices exist to ease the difficulty of a litter carry, and they include things like straps or handles, litter wheels that allow for us to almost carry them and move them almost like a wheelbarrow. All of those allow for us to have a much easier way of transporting that patient without risk to the rescuer or to the patient. For low angle and high angle evacuation, they again require specialized knowledge and skills, and that we should be utilizing an evacuation team to assist with any efforts they need from us. We also may need to use some type of aerial apparatus like a tower ladder or a bucket truck, especially when we're utilizing a Stokes basket, as we need to lift and to lower that to belay or to lower the litter. We may also see the use of helicopters in rescue operational components. We know that helicopters can be useful in hazardous terrain rescues, but we have to understand what the capabilities are of the helicopters in our area. Some are going to have advantages and disadvantages. Maybe easiest for that helicopter to get in, but if there's a lot of loose soil or dust, maybe that's going to stir up the environment, making it more difficult to gain access or to care for that patient. Things like boarding and deboarding practices for safe loading and unloading during the helicopter. Again, we recognize from our landing zone class that we should never approach a helicopter where the rotor blades are moving, nor should we ever approach it from the rear tail fin. We know that there's going to be restrictions on what equipment they can carry versus potential crew versus non-crew members. We've got so many capabilities and weight limits that we can use for cables and winch rescues. Again, we talked about those weight restrictions. We can only do so much when we need a helicopter to hover or maintain them for a period of time. And use of short hauls or sling loads of equipment may be possible to get equipment in and out, as it can lift and lower that equipment in very remote regions or areas where getting equipment may be very difficult. Remember, when dealing with evacuation techniques, that you need to be familiar with your equipment. You need to make sure that you practice your skills regularly and require for low angle and high angle rescues when you have that specific training. But be familiar with your local resources. Remember, practice like you'll perform. That's going to be critical in your care as a paramedic. For extended care assessments, consider protocols that address the following areas. Maybe long-term hydration management. Maybe we're going to be dealing with repositioning of dislocations, cleaning and caring for wounds, removal of impaled objects when it's necessary. All these things require specialized training and specialized protocols, but we want to know what's available in our area so that you can optimize your patient care, especially if you're going to be there for a long period of time. We also have to recognize environmental issues when we're having extended care. Things like weather and temperature extremes. Are we going to be able to have full access or only limited access to our patient? And what type of difficulties may we have of getting our equipment into our patient? And then we may also have to try to work in very cumbersome like PPE to protect us while trying to save and rescue the patient. We also know things like patient exposure, the ability to provide advanced life support care, patient monitoring, and oftentimes we have to improvise, overcome, and adapt in order to carry out the mission at hand. In summary, we've talked about the role of the paramedic, the necessary protective equipment for both you and your patients, safety procedures, recognizing that safety is everyone's responsibility. We talked about rescue operations and the procedures in which we need to implement throughout those 7 phases of a call. We talked about surface water rescue for both bodies of water and swift moving water. We talked about hazardous atmosphere rescues and the concerns with lack of oxygen in those environments, and the potential for other hazards. And then highway operations as one of the most dangerous aspects of EMS that we deal with, along with proper vehicle rescue and knowing that the technology in vehicles today pose a bigger risk to rescuers than they have in years previously. And last, we talked about a number of different types of high angle and low angle hazardous rescues on different types of terrain and the equipment utilized. I hope this lesson has been valuable to you. And again, pay close attention to some of the other assigned reading and videos throughout this lesson, as they'll prepare you to be a competent entry-level paramedic and work with those experts who have the training and the equipment to perform these field rescues. I'll talk to you guys in the next lesson.